Yes, hello. So, how are you all? My name is Deviation. We are doing statistics standard 11. In last lecture, we had seen the topic of standard deviation. Standard deviation till now, we had completed standard deviation for raw data. That is, when only xi is given. Then, in last lecture, we had started standard deviation for discrete frequency data. That is, when fi xi both are given. I taught you two kind of formulas there. That standard deviation is fi xi minus x bar whole square upon n root, and standard deviation is equal to sigma fxi square upon n minus x bar whole square root. Okay. In that we had seen a sum, and we had solved that sum with both the formulas. That is, with the previous one and the next one. Let me revise you all the things what we have done. In the first formula, we had solved x bar first. What was x bar? It is phi xi upon n. Phi xi is very simple. You have to multiply xi into fi. After solving x bar, that is mean, what you had to do, you had to find x minus x bar. X minus x bar means you have to subtract x bar minus x. Okay, so x is 0, 1, 2, 3, 4. You have to subtract 2, that is x bar, 1 by 1. After subtracting mean from x, you have to do the square of that column, that is x minus x bar whole square. After that, you have to multiply that x minus x bar whole square with frequency into fi. So you are getting fi x minus x bar. Then your standard deviation is fi x minus x bar whole square upon n's root. Okay, so you are getting the answers. Then we have done the second formula. In second formula, these steps are common up till fi xi. You have to find a column which is named as fixi square. This fixi square is not fixi whole square. This fixi square means fixi into xi. That means there is only square of xi. You had solved fixi, so just you have to multiply xi with the fixi. So this is fxi square upon n minus x bar. Okay. So now what we will do, illustration 15. Let us do illustration number 16. In your textbook, they have used a different method, that is shortcut method, but we are not going to do that method. Okay. They have solved the coefficient of standard deviation. So what is coefficient of standard deviation? Let us write the formula for that also. I taught you in standard deviation. Coefficient of standard deviation means standard deviation upon. Just see, when you are finding standard deviation, you have to find mean. So you have both the things, mean also and standard deviation also. Just divide it and you are getting the coefficient of standard deviation. So there is nothing more to it. So let us find the illustration number 16 now. So what data is given? Number of mobile phones sold. 5, 6, 7, 8, 9, 10. 2, 5, 6, 2, 5, 8, 12, 7, 1. That is 35. Now fixi. Okay, so let us find fixi. What is this frequency actually? Number of days. So my x bar is fixi upon n. Okay. So now what is my fixi? It is 265 upon 35. 7.57. This is 7.57 mobile phones. The answer. After finding this x bar, I'll be finding the fxi square. I'll be using the second formula to find the standard. My total is 2057. This is fixi into xi. Okay. Now my standard deviation will be fxi square upon n minus x bar was. So it's 2057 upon 35 minus x bar. 8.77 minus 7.7 into 7.57. Now this 58.77 minus 57.3, 1.57. Root of this 1.57. So answer is 1.20. We got 1.21. So there may be some rounding off, you can say, thing, but it is fine. This is 1.21 mobile phones. Okay. So I got this standard deviation, this formula. They told me to find coefficient. Because question was asked like find the coefficient of standard deviation. Use shortcut method. This kind of question will not be asked in your exam. That use shortcut method. You will be asked freely the question that find coefficient of standard deviation. Okay. No method will be specified ever. Now to find coefficient of standard deviation. Your formula is standard deviation upon mean. Now your standard deviation is 1.21 upon. What was your mean? Mean is 7.57. Okay. So this is 1.21 upon 7.57 is 0.16. So now this is your coefficient of standard deviation, and this is not in mobile phones obviously. This time in this kind of units you cannot write at the end of coefficient because coefficient is n relative measure and it is always unit. Okay, I taught you two type of measures, absolute and relative. This is known as absolute measure because it has unit. This is known as relative measure. It does not have any kind of unit. It's 0.16. Okay, there is no abbreviation used after that 0.16. Okay, done. So again, the kind of sum we are solving of FI from this exercise. Yes, 4.4's third question. For the following frequency distribution represents the amount of deposit and the number of depositories in a bank. Find the coefficient of standard deviation of the deposits. Deposits is 1,000 rupees. Number of depositories. This is illustration. No, this is 4.4. Deposit 1,000 rupees. 5, 10, 15, 20, 25, 30, 25. Frequencies in number of depositors. 2, 7, 11, 15, 10, 4, 1. This is 2 plus 7 plus 11. That is 50. Now what is this FIXI? 10, 70, 165, 300, 215, 120. Okay, so my FIXI, total of FIX is 10, 70, 165, 300, 250, 120 and 30. So this is 950. So with this my X bar will be 950 upon 50. This is 1919. Now, as a X bar is in, you can say a round digit 19. You can use the first formula x minus x bar, then x minus x bar whole square, and then fi into x minus x bar whole square. You can use that also. But if you want to do the continuity, that means what we are doing is fine. Then let us not change the method. Let us not change the VFXs. Now FXI into XI. This 10 5s are 50. 7 10s are 700. 165 into 15. 2475. Then 300 into 20. 6000. Then 250 into 25. 6250. 120 into 30. 3600. 35 into 35. That is 1225. Now 50 plus 700 plus 2475 plus 6000 plus 6250 plus 3600 plus 1225. It's 203 double zero. This is my FXI square. So let us find the formula. Standard deviation is equal to sigma FXI square on n minus x bar whole square. So this sigma FXI square on n minus x bar square. Answer is 6.7. Okay. This everything is in 1000 rupees, so this is 6.71 thousand rupees. You can You have to find the coefficient of standard deviation. So let us find the coefficient of standard deviation. This coefficient of standard deviation is equal to standard deviation upon mean. So this is 6.71 upon 90. 0.35. So now my answer is 0.35. Let us find the answer. This is exercise 4.4, third question. So standard deviation is 6.71 and the coefficient of standard deviation is 0.35. You can see the answer is proper. What we can do, we can find this particular sum with this formula also. In the same sum we can find it. First of all, what we'll do, we'll be finding x minus x bar square. First of all, we are finding just x minus x bar. Now let us not find the square. Let us not find the square, just find x minus x bar. Now your x bar is actually 90, 1990. Okay. So my x minus x bar is 5 minus 19 is minus 14. It's minus 9 minus 4. 20 minus 19 is 1. 6, 11 and 16. Then this is x minus x bar square. Now your x minus x bar square is actually 14 into 14. It's 196. 9 into 9, 81. 4 fours are 16. 1. 36, 121 and 16 into 16. 256. Now again I have to find the next one, which fi into x minus x bar is. Now fi into x minus x bar whole square, that is 196 into 2, 392. 81 into 7, 567. 16 into 11, 176. 1 into 15, 15. And 36 into 10. 360. 196 into 2, 81 into 7, 16 into 11, 15 into 1, 36 into 10, 121 into 4, 484 and 256 into 1, 256. Now I have to do the total of this particular one. 392, 567, 176, 360, 484, and 250. It's 2250. My standard deviation is sigma fi x minus x bar whole square upon n's root. So now the sigma fx is minus x bar whole square is 2250 as I told you. Upon what is my n? That is total number of frequency. My total number of frequency is 50. 2250 upon 50. This is 4050, 6.71. So this is 6.71. So my answer is same with both the formulas. Next lecture we'll be doing standard deviation when classes and frequencies are given. Okay, so till then you have to practice this sums. You have to solve the sums in your book whenever you are watching the lecture, and uh, if it's possible, then you have to do this sums without seeing also. Okay, so that you can learn the formulas also, and you came to know that how much you have remembered. Okay, so that's it for today. Thank you.